Hi, I'm Ken Adams. I'm a geology professor, research professor at the Desert Research Institute in Reno, Nevada. And I'm doing a series of these videos just to kind of show some of the field settings that I spend some time in and find fascinating, and just to share a little bit of this geology with, well, and my dogs with you. Lucy is very excited because she gets to go into the field today. Me too. So, where are we? We're in the Carson Sink. Right now, we're in the eastern part of the Carson Sink, and technically, to my left is referred to as, I believe, 4 Mile or 8 Mile Flat. I might get them reversed, one's further east than the other. And then on my right is the Carson Sink. I can see the Fallon Naval Air Station, I don't know, 10 kilometers away. Just to the north here, those are the Lahontan Mountains. And those mountains there, that's basically, well, what am I trying to say? Roger Morrison, who was a USGS geologist, very famous, very smart guy, he started working out here in the 1940s, late 1940s. And just a lot of these hills and mountains didn't have names, and so he had to have names put on the map so he could say the type section for the Itza Aloe Formation is here in the Lahontan Mountains. And so all of the place names, a lot of the place names around here were named by him. Lahontan Mountain, the low hills, the very rounded highest one is actual Itza Mountain, and Itza is also the name for the penultimate lake cycle out here. Sehu is the youngest lake cycle. And just to the south, when we walk around, I'll show you this, are called the Bunjug Mountains. And these were named by Roger. I guess his grandson, the story goes, is that his grandson couldn't say Junebug, not walked around looking at these Bunjugs. And so he named it that. And, you know, they're not that impressive as far as mountains go. But again, he needed place names for when he was mapping and so forth, so he could say certain things were at certain places. So what we're standing on is a very large gravel boulder spit that has been built by waves off the north end of the Bunjugs, and we're almost at the tip of it. Probably goes for another couple hundred yards or so. And most of this to the south, it extends for, I think it's more than a kilometer, a couple of kilometers, to the northern tip of the Bunjugs. And as far as I know, there's no bedrock between here and there, and so all of the rocks that comprise this constructional landform, it is a gravel spit, were moved by waves from that direction, a kilometer or two away. And as we walk around, I'll show some really big boulders out here. And these aren't Yakulops or glacial outburst floods or nothing like that, because there's no rivers here. This was a lake. And so this was wave activity that was caused by strong winds moving across the surface of the Carson Sink. And the Carson Sink happens to be the largest basin in the Lahontan system. And I don't know exactly what the fetch is when I'm looking off to the northwest here, but I think it's like around 50 kilometers. It doesn't get much bigger than this in the Lahontan Basin. And so consequently, there could be very large waves that were formed during strong wind events, and that wave activity is what moved these rocks out here. We'll see if that makes sense in terms of sort of the magnitude of the size of the waves versus the boulders after we look around a little bit more. And so I say it's a spit. What do I mean by that? Well, the left side of this thing has been bulldozed, and for a good part of its length to the south, actually, it's a gravel pit, a linear gravel pit that was dug along the crest of this feature. And so, gravel pits can be a geologist's best friend because they form exposures that you can check stuff out in, and there's a lot of beach deposits and other things exposed. As a matter of fact, there is the Wono tephra. It's a volcanic tephra that was erupted from one of the Cascade cones around 27,000 years ago, is found in beach gravels there, and we'll go and take a look at that in a moment. But let's get back to this thing, the spit, the surface of this. So we're going to walk around, take a look. So this is the back slope of this thing, and how I know that it's the back slope, meaning that the waves were coming from behind me, the way I'm looking the same direction as the camera right now, and cascading the water and the sediment down the backside of this feature, forming what were probably backsets, and these sedimentary features are exposed in the gravel pits here. And so as we walk along the crest of this little sand spit, it's not a sand spit, I mean, look at the size of that boulder. It's relatively narrow, maybe, I don't know, 15 meters across, and it gently slopes to the north, and where it just sort of dives down into that playa and where the dunes are off in that direction. So what's this elevation? This is a relatively low elevation in this basin for lakes. I think we're around 1205 here, 1204 meters. And the last Lahontan high stand was around 1338 meters. So 110 meters, over 300 feet of water on top of where we're standing right now, 15,000 years ago. And as a matter of fact, in another stop, I'll be talking about the Holocene lake level record out here. And there's a Holocene lake, the medieval pluvial shoreline, that is at about the same exact elevation. So, and that happened in 1100 AD, or just about 850 years ago. So that was very recent that there was a huge lake. But I'll save that for another time. So we have this sort of spit feature we're standing on. There are clasts, everything is pretty angular. And so you'd say, well, why? How do you know that that's beach gravel? And part of it is there's lots of tufa fragments on this feature as well. And so here you can see all these are tufa fragments. It's a calcium carbonate precipitate. It tends to precipitate on stable landform features such as big bouldery deposits like this, cliffs and so forth, and it forms like a carapace, and you can see some of this on this particular clast right here. But all these other chips are pieces of these coatings that were on a lot of these rocks, and we'll see better examples of this. So there's a lot of tufa chips here telling you that it was a beach. There's also a lot of silt in here, so it's not pure gravel, at least at the surface. So is this silt that's blown in here and has been inflating this surface, sort of like the formation of an AV? I'll bet you it has vesicles in it. I left my shovel in the truck, so I can't poke into it, but I'm guessing it does. Or is this a deep water lacustrine deposit that was laid down on top of this feature when lake level rose above this? You know, through much of the late Pleistocene, the lake was at a much higher elevation than in this right here at around 1200 to 1205. So the guys that were taking the gravel, they're also doing some recreational bulldozing or excavating, like this little pit right here. And these are ubiquitous in the landscape out here. Whenever you see a gravel pit, there's potential to see some nice exposures and the soil development, and commonly they dig them in beach gravels, beach features, because it's such a good source of gravel. And sometimes it's very smooth. A lot of this gravel is rounded that came out of here. This is mostly basalt in terms of lithology, or andesite, or andesitic basalt, or basaltic andesite. It doesn't really matter to me. It's some sort of mafic volcanic. So, well, it does matter sometimes if you're tracing a particular exact rock type. Sometimes you can trace it in these beach features to figure out which direction the shore drift was going, i.e. where the waves were coming from. So, not going to dig out this, but you can kind of see this sort of silty cap, the upper 50 centimeters on this. Is that Aeolian introduction? Is that some sort of deposit from a deeper lake? I'm not sure, but you'd have to dig around a bunch and try to figure that out. So next we're going to the tephra outcrop.